Colleen Rosales, a PhD candidate in environmental science at Indiana University. I'd like to welcome and thank you for stopping by my poster booth today. I hope you find it easy to navigate and view the full version of my poster. And if you have any questions, please feel free to leave them in the chat box or send me an email. I hope you enjoy my short presentation of the highlights of our research. This current study deals with indoor mopping with a terpene-based cleaner in the presence of ozone and how we were able to detect the rapid formation of peroxy radicals, volatile oxidation products, and secondary organic aerosols during these mopping periods. This project is in collaboration with Purdue University, RJ Lee Group, and IMT Lil Dewey. Currently, volatile organic compounds from chemical products have become more important in the urban chemical mix. And recently, we've been cleaning more, disinfecting more surfaces, and thus using more of these products that emit primary VOC emissions. And in addition to that, their chemical reactions with indoor oxidants such as ozone, OH, and nitrate radicals form intermediates such as HO2 and RO2 and oxygenated VOCs that eventually lead to the formation of secondary organic aerosols. This phenomenon is not new. It has been known in the outdoor environment to be a source of particle pollution. However, in the indoor environment, the extent to which this phenomenon happens is much less understood. And why is it of concern? Because exposure to particles may lead to acute respiratory and sensory irritation, as well as a heightened risk of mortality from respiratory disease. And again, in the indoor environment, we want to know how much of the secondary aerosol particle formation occurs. And to address that, we did a household mopping simulation at the IU Research and Teaching Preserve under the campaign called IRACE, which stands for Indoor Radical and Aerosol Chemistry Experiment. So this was done in the summer of 2019. We cleaned surfaces using a commercial terpene cleaner. So this test room is a 21 square meter room. Mopping and wiping of surfaces were done. The outside air is coming in and being recirculated in the room. Air exchange rate was determined to be 4.5 per hour. And surfaces, as I mentioned, were mopped and wiped for 10 to 15 minutes at a time. We did multiple trials in a day, and the cleaner that was used contains the limonene and possibly other findings. So again, we were able to track from the very beginning of the emissions and see the transformation to secondary organic aerosols. So to track this whole process, we used many different instrumentation. First of which is the proton transfer reaction mass spectrometer to track primary VOC emission. And then for indoor oxidants, we measured ozone using an ozone analyzer and OH radicals using a laser-induced fluorescence assay by gas expansion or LIF stage. To detect intermediates, we use both LIF stage and PTR-MS. The LIF stage to detect HO2 and RO2 intermediates, and the PTR-MS to detect oxygenated VOCs. And lastly, to detect secondary organic aerosols, we used a suite of aerosol sizers to cover the whole size range from 1 to 10,000 nanometers. Here, I show the time series of the first two mopping periods that we did. The first mopping period right here is when the sunlight was coming in the window, and the second mopping period was there was indirect sunlight coming into the window. The first panel shows primary emissions. such as monoterpene and another organic primary emission. The next panel shows ozone, and as you can see here, during this mopping period where we see an increase in the monoterpene, we see a decrease in ozone, signifying some reaction between the two. In the third panel, we see that radicals are formed independent of the amount of indoor sunlight. We see that the levels in HO2 are about the same for the two mopping periods. In the fourth panel, we see the formation of selected oxidation products, and we know that these are secondary oxidation products because of the delay of the time they were measured. Lastly, we saw the formation of secondary organic aerosols after this time of mopping, and we see this burst phase of very small particles, 1 to 3 nanometers, which are nucleation phase particles and indicative of new particle formation during these mopping periods. Note that ozone is about 10 ppb or less inside the home. And so this is significantly lower than what would be expected outdoors. With that, we were able to track the formation of SOA from the emissions of the primary compounds or primary VOCs up to the formation of the intermediates, and lastly to the formation of the secondary organic aerosols. And we also did an evaluation of inhalation rate and respiratory tract deposited dose rate, or RT-DDRs, as estimates for human exposure and dose. We saw that there is an accumulation of both number and mass respiratory tract deposition dose. And you can see here that there is a huge number of SOAs formed during mopping that tends to accumulate. And this tells us that a person, for example, who mops the whole day, say his occupation, or someone that obsessively cleans, and during these times, of course, we're always cleaning and disinfecting inside our homes or, surfaces in our workplace. And there is a possibility of accumulation of the SOAs formed during these periods of time, not only in the air that we breathe, but also in our respiratory tract. And in addition, we also did comparisons of the RT-DDR to outer polluted environments, such as an urban environment and a street canyon. So this urban environment is somewhere in North America, and a street canyon in Finland. Note that these two, the size range is just a slice of what we have measured during the terpene mopping. And so this terpene mopping period show a larger dose rate for this size of SOA and particles. What this means is that the inclusion of the other size ranges are also significant in terms of assessing the dose that people get from exposure to secondary organic aerosols. In addition, we can also glean from here that exposure to a short period of mopping can be equivalent to standing in a street canyon with heavy traffic for 1 to 4 hours. And so in that short amount period of time, we're exposed to what we can call as an indoor smog inside the home just by cleaning with such types of cleaning products. And as a conclusion, daily activities in the household, such as cleaning, can be huge modifiers for indoor air chemistry, as we have seen from the primary VOC emissions to the intermediates, and lastly to the SOA formed, even in conditions that may be significantly different from the outdoors. And so with just a burst of monoterpenes, and low concentration of ozone, we can change the chemistry in our indoor environment. And aerosol production from specific types of cleaning products have been shown to be comparable to outdoors. And the secondary pollutants are much as important as primary emissions in terms of health effects, as shown by the dose rate calculation. Prolonged this exposure is almost equivalent to being outside in an urban environment or like in heavy traffic. And there's also the possibility of accumulating in the respiratory tract. And this is most important for people who obsessively clean and people who work jobs that require cleaning, for example, custodial staff. And especially now, most of us clean our surroundings and disinfect our surfaces more often. This probes us to be more conscientious of the types of cleaning products that we use for cleaning and disinfecting our indoor environment. And with that, I'd like to again thank you for stopping by and staying. And if you have any questions, please feel free to leave your questions in the chat below or send me an email. And please feel free to browse and view the full PDF version of my poster. We also show there's some modeling results where we compared our modeled SOA concentrations as well as modeled intermediate to what we have currently measured and how these compare and what discrepancies, if ever, arise. And again, thank you for stopping by and stay safe.